Hi, in this video I am going to discuss BCD to 7 segment decoder. The BCD to 7 segment decoder or driver ICs are used to convert the BCD signal into a form suitable for driving the displays. BCD to 7 segment decoder is a combinational logic circuit which converts the BCD 4-bit code to 7 segment display code. The 7 segment display codes are 7 bits. This is the block diagram representation of BCD to 7 segment decoder. The inputs are A, B, C, D and the outputs, 7 outputs are A, B, C, D, E, F and G. A 7 segment display is shown in figure. It has 7 flat LEDs arranged in such a way to display decimal numbers from 0 to 9 and other symbols. The 7 segments are labeled as A, B, C, D, E, F and G. So these 7 segments are considered as LEDs. This is one LED, this is second, this is third, this is fourth, this is 5, this is 6 and this is 7. So total 7 flat LEDs are available. When LED segments A, B, C, D and G are on, we get the number 3 as shown in the figure. The display patterns for numbers from 0 to 9 are shown here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The display pattern is represented here. Generally, two types of 7 segment display modules are available. One is common cathode type and another is common anode type. So here this is common cathode type and this is common anode LED type. So in the common cathode type, all the cathode terminals are connected together and it's connected to ground terminal. Then in the common anode type, all the anodes are connected together and it is connected to the power supply. So this is the difference between common cathode connection and the common anode connection. This is the truth table for BCD to 7 segment decoder for common cathode method. The 10 BCD inputs are 0 to 9. The BCD inputs are considered as A, B, C, D and the 7 segment outputs are A, B, C, D, E, F, G and the display patterns are here. Now for example, to display number 0, all the LEDs are glow except G. So when 0, 0, 0 condition displays 0 is presented. So in this condition only G LED is 0, remaining all LEDs is glow. Now for 1, these two LEDs are B and C. These two LEDs are high, remaining all LEDs are 0. For displaying number 2, this LED and this LED is on, off, that is C and F is on. This is C and this is F and remaining all LEDs are glowing. Similarly, we are making we are arranging the tables. For all the 10 combinations. From the truth table, we are obtaining the SOP expressions for each output A, B, C, D, E, F and G. And here the input is BCD. So the don't cares are considered as 10 to 15. This is the K-map simplification for all the 7 outputs. First, these two are the K-maps for output A and B. We are placing the ones to the corresponding cells and we started grouping. And these 8 cells are grouping into one cells and these 8 cells are grouping into another cells. And this one is grouped with these 4 cells. And all the corner ones are grouped into another cells. Now we start the expressions. Let's start with this one. Here the common between these two is these two cell is C. So C is written, and here the common between these two is A, and here the common between these two cell is B. Here the common between these two is D. So BD answer, and this all four corner groupings, the common between these two is B bar, and the first and last cell common is D bar. So B bar, D bar. Next, coming to here for B, these four cells are grouping into one single cell, and these four cells are grouping into another single cells, and these four cells are grouping into 8 cells grouping. So the expressions are here C bar, D bar, and for here CD, and for this case the common between this one and this is B bar. This is the K-map representation for output C and D. First see about expressions for output C. Here these four cells are grouping into one cell grouping, and these red cells are grouped with the 8 ones, and here another 8 cells grouping. So 3 8 cell groupings are available. So for yellow color grouping, the common is C bar, and green color grouping the common is D, and for the red color grouping the common is B. So B, C bar, D. For the output D, here we can combine into 8 cells grouping, and this ones we can combine with this one only, so 2 cell grouping, and this one we can combine with these 4 cells, and this one is combined with these 2 cells, so it will make it as 4 cell grouping. Now this one we can group it into all corner ones. Now we will write the expression for this blue color cell grouping. The common between first and last is B bar, and the common between these two is D bar, so B bar, D bar. Next, the green color grouping, the common is A. Next, yellow color grouping, the common between these two cells is B, C bar, D. And here for the purple color, C, D bar. And for the red color, the common between first two is B bar, and here C. And this is the K-map simplification for outputs E and F. First see about output E. These 4 cells are grouping into one cell grouping, and this one is grouped with all corner ones. So only 2 combinations are available for this output. So the output for this combination is B bar, D bar, and for this combination is C, D bar. Now for F, we have total 3 cells grouping. This red color is combined into total 8 cells, and this one is grouped with these 4 cells, so it's make 4 cell grouping, and this one is combined with this 4 cell grouping, and this one is combined with this 4 cell grouping. So for red cell grouping, the output is A, and for green cell grouping, the output is C bar, D bar. And for yellow color grouping, the output is B, C bar, and for the blue color grouping, the output is B, D bar. This is the output expressions for output G. Now in this K-map, these 2 ones are grouping into 8 cell grouping, and these 2 ones are grouped into 4 cell grouping, and this one is grouping into 4 cells grouping, and this one is grouped with the 4 cell grouping. This one, these 2 ones and these 2 ones are grouped. Now we will write the expressions for red color grouping. The expression is A. For yellow color grouping, the expression is B, C bar, and for the green color grouping, C, D bar, and for the blue color grouping, the common between first and last cell is B bar, C. So from the K-maps, we got the Boolean expressions A to G, that is given here. Based on the logical Boolean expressions, we have drawn the logical diagram for each output. So this way we can draw the logical diagram for each output. Thank you.